So I'd like to make a correction in one of the previous videos that I made based on a pressure problem where we tried to find the value of H, which is the change between the height of this water level here and the height of this water level here. So in that video, I mentioned that H1, this value over here, was the height from the very top of this first reservoir down to the point of contact between the water and the mercury. So what I didn't mention was the specific value of H1. So H1 should be equal to H H, the value of this height, and then plus an extra distance, we'll call that H2, and then plus the value of the manometer reading. So this is going to be H plus H2 plus 0.25 meters. Okay, so that's the full height from the very top of the reservoir down to this point of contact. Okay, so this H2 here is the same as this H2 over here. And so H2, remember, is just the distance from this point of contact to this point here, which is the same as the water level height for the second reservoir. Now, down here, we have rho W times G times H1 minus H2. Now, H1 minus H2 is just this value here minus H2. So that means H1 minus H2 is just H plus 0.25 meters. Okay, so that's the value that we should have here. In the last video, I mentioned that this was simply H, right? H1 minus H2 was H, which is incorrect. It should be H plus 0.25 meters. So we can actually write rho of the water times G times H plus 0.25 meters is equal to rho of the mercury times G times 0.25 meters. Okay, and if we solve this, we find that H is equal to rho M over rho W minus 1 times 0.25, and this gives a value of H equals 3.15 meters. Okay, so this is the correct value of H for the problem, not 3.4.